Hello, everybody. Video number 3, first real meats and potatoes lecture video. So after today, you will be able to describe the steps required for a chemical reaction to occur, talking about collision theory. So this is for the POGL. And for the lab, predict how changing concentration, temperature, and surface area will affect the reaction rate. Will I speed it up or will I slow it down? So what are chemical kinetics and rates of reactions? This really is just formally the study of the rates of reactions. How fast does the reaction go? We need to know how fast, because we need to know is it slow or fast. Okay. The rates of the reactions can be manipulated if the conditions of the collision theory are manipulated. So we got to get into the collision theory and what that is. Okay, so let's do that. Oh, here we go. Reaction rate, collision theory, reaction mechanisms. So nature of reactants. Ionic versus covalent reactants. That's what nature of reactant means. So you need to write in the side here, ionics react fast, covalents react slow. So that's simple. Covalents have a lot more bonds in there to break. Ionics have simple bonds in between the ions, so less bonds. Covalents, when you get into organic, you'll see that these molecules can be huge and there could be potentially hundreds of bonds. Okay, ionics react faster, period. So how do I make it go faster? Use an ionic. Okay, the number of steps in the reaction is what we term as the reaction mechanism. So the number of steps in the reaction, less steps, faster reaction. That's simple. That's something we can't really manipulate. That has to do with what the chemicals are. But it'll help me know, is it a fast reaction or a slow reaction? And that's honestly more of a college level type stuff. We're not going to get too much into reaction mechanisms. I just want you to, as a chemistry student, know that they exist. Cool? Then what is collision theory? So here we go. These are the rules that every chemical reaction needs. We're going to have a chemical reaction for lab. You are going to have to manipulate it. You're going to need to know these things. So a collision between reactant particles must occur. First, there must be a collision. Boom. Okay. Then the collision must have enough energy to overcome the activation energy of the reaction. So I have to have enough energy to get them to actually react. Break bonds, make bonds. Okay. Then the collision must occur with the correct orientation so the reactant particles can merge. Very much like when you guys did enzyme substrate in living environment, lock and key, and it fit in perfect. Well, if it comes in the side and it's supposed to fit here, well, it's supposed to fit like this and it comes in like this, does it work? No, it actually has to come in the right way. It can't come in this way, or this is the way it needs to come in. It can't come in this way. Okay, so that's what we mean by orientation in space. So we can manipulate that in certain ways. Generally, the more collisions, the more chance I have for that probability to happen. A lot of probability here with these collisions. What makes an effective collision? Any collision of reactants with correct energy and orientation will result in the reaction. So we need as many of those effective collisions to happen as possible. More effective collision, more reaction. Hence increased rate. These are some things that you can do to change the rate of your reaction. So if I increase the concentration, the reaction rate will increase. So is more stuff. Higher concentrated acid will react faster than lower concentrated acid. Okay. If I decrease the concentration, I will decrease the rate. Okay, that's what I'm trying to say there. You can do arrows or you can take notes, whatever makes sense. Okay. If I increase the temperature, I will increase the reaction rate. Temperature is kinetic energy. If I get them moving around faster, the probability of more collisions happening increases. That's something that's almost inherently obvious, but I can't have you overlooking that. That's one of the most fundamental parts of the entire unit. More collisions, more reaction. How do I get more collisions? Heat it up. They start moving around faster, they're most likely going to collide. It's kind of like bumper cars. You got bumper cars going around really slow, or you got bumper cars going around really fast. How many more collisions do you have that are effective that makes your head go boom, right? There we go. Increase the reaction rate, increase the temperature. If I decrease the temperature, I will slow it down, and I'll make it go slower. Okay, good. Pressure, and then notice it says only for gases. So if I increase the pressure, decreasing the space in between them, they're more likely to collide. So the probability of collisions goes up, the reaction rate goes up. Okay. Opposite is true. If I decrease the pressure on specifically gases, I will decrease the reaction rate. Surface area, break it up. A chunk versus a ground powder. A ground powder has much more surface area in the same mass. More surface area means more contact sites. More contact sites means more chance for correct orientation, hence increased rate. Okay, good. Decreased rate. If I decrease the surface area, if I keep the thing whole, I will make the reaction go slower. Catalysts. Adding the right catalyst will increase the reaction rate by lowering the activation energy. That's it, because guess what? There is no decreasing for catalysts. Catalysts do one thing and one thing only. They lower the activation energy. Got it? So that's it. There's 3 videos up. Enjoy yourself. Now I find the button and I press the button. Oh, don't you